No, I'm not showing my screen, and reason being, I just got done shoveling the walk. I haven't taken a shower yet, and I really don't want to scare you, so that's why you're just seeing a picture of me. Is that okay, Jolene,
That's fine by me.
Stacy, Jason?
Okay.
Hello.
Yep.
If I put my speakers up, maybe that'd be great. All right, try this again. Everybody hearing me?
Yes.
All right, who's that? Stacy?
Yes.
All right, and where everybody else is, I don't know, but I gotta get started because I got a lot to do. Attendance has been pretty good. You know what kills me is, all right, so this is a snow day. I mean, people look for reasons not to do stuff. All right, so it's a snow day. We're not meeting on campus. I mean, at least the six of you had the common sense to log on, but people are always looking for ways. But I'm moving on. The course is the course. I mean, we got stuff to do, so I'm not gonna say much about that. You're here. The rest of the folks aren't there. That's on them. You understand, right? Hello.
Yes.
Yeah. Okay. You guys are calling. Who's more? That Stacy? That you?
No, it's only me.
Don't get mad at me, Jolene. Don't be yelling
I'm
at
not mad.
me. Early in the morning to be yelling at me. All right, I'll get started here, and I'm recording this, and I'll post it like I always do. All right, I want to start off by sharing my screen. And the first thing that I want to show you is today's homework. All right, first thing I want to show you here is that we have an exam on Wednesday the 17th. Now, I originally had scheduled this exam for the Monday. Now I get it. It's on the calendar for the college that Monday is President's Day, the 15th. So there will be no assignments after you do Wednesday's homework. You've got basically Monday off, but spend that time obviously preparing for the exam on Wednesday. Now, if you haven't taken any exams on Canvas, here's what you need to do. Even though there are exams on Canvas in this left hand menu, they're denoted by quizzes. It's an exam, but Canvas calls it a quiz. So, what you'll do on the 17th, you'll click on quizzes. Now, you see two here, you'll only see one. All right. And there's a reason that there's a second one, and you really actually don't need to know about that. Once you click on it, well, all right, you'll see the directions. You got 90 minutes to complete the exam. Once you begin, you must complete it in one sitting. Now, the reason I say that is the exam will open up at 12 o'clock on Wednesday the 17th. All right, we'll have a Zoom. Well, what we'll do is I'm moving our Monday Zoom to Wednesday. All right, instead of meeting at 11 o'clock on Monday, we'll meet at 11 o'clock on Wednesday. And we can use that hour, to ask any questions you may have, for the exam. Now, the exam covers chapters 1, 2, and 3. So that's section 1, 1, 1, 2, 2, 1, 2, 2, 2, 3, section 3, 1, I'm sorry, 3, 1, 3, 2, and 3, 3. So it covers 3, 6, 8 different sections. So we'll use next Wednesday's Zoom meeting. You can ask any questions that you may have. Here again, as far as the directions, once you answer a question, you can't go back to previous questions. And there are no allowance for any redos or anything else with these exams. So 90 minutes will be plenty enough time for you to take the exam. All right, so that's where you'll find it under quizzes. And let me go back to my home page here. Very important is that we've talked about statistics being, hey, how do I collect data? How do I organize it and analyze it and the like? Well, we're now to a point where we're making use of the TI calculator big time. Now, back on last Wednesday's homework, back on 2, 3, what I've got here, and hopefully you've watched this, is there I've got 1, 2, 3, 4, 5 different videos working with the TI. And now we finally start to work with what's called lists. Well, you got all sorts of videos here to tell you or show you step by step how you put values into the list. Now, I'm hoping that the majority you have the 84 and not the 83 because things are a little bit different. But if you have the 83 and you have a question, please email me because it is slightly different. But you can see why at the beginning of the course, I told you if you were if you were borrowing a calculator from the college or if you were going out and buying one, please get the 84 because the 83 was slightly different. All right, so hopefully you've watched these videos and you're ready to go. And of course, the phone would ring. I'm gonna mute myself for just 1 second because I need to take this call. All right, sorry about that. That was a nurse calling in regard to my mother. So, anyways, home exam one on the 17th. You've got all these videos. Please take a look at that, especially these guys here on how and truth being known, I've got a lot of video, but you type in TI 8384 on YouTube, you'll find hundreds and hundreds and hundreds and hundreds of videos. All right. I I think I found some of the best ones here for you, but there's all sorts of resources. And of course, you can email me. It's something else too. My Friday optional office hours meeting, I've only seen two people in 2 weeks. I'm available. I'm available. You know, I can't answer a question that, you know, that you don't ask me. So
I have a question.
yeah, go ahead.
Are you available like any other day if we're not able to make the
Yeah, shoot me
Friday
an email.
meeting?
I'll let you know. I mean, my schedule is off and on, but you know, I don't, you know, you got to email me and I'll, you know, tell you my availability.
Okay.
All right. I'm
Thank you.
always available by email, you know, but I can, you know, I can arrange my schedule. I mean, I'm busy like you folks are busy, but I'll find time. You follow? Hello?
Yes.
Okay, thanks. All right. So let's look at today's homework. Yeah, I do, you know, Zoom meetings one-on-one with students. I'm here to help you. You know, we'll arrange something. All right, so tonight's homework, you get your exam here again on Wednesday the 17th. You'll find it over here on quizzes. Um, there's two PowerPoints, two voiceovers. What I'm going to do today, I'm going to try to get through 3, 2, and 3, 3. But you'll see them here where I have my voiceover. So basically, these two things, what I'm going to try to do today is my PowerPoints. I'm asking you to do to practice. Section 3, 3 is the toughest. It starts to get a little grimy now. 3, 3 challenges you. All right. Stuff has been fairly basic. But make sure you watch the videos, do the PowerPoints, watch the videos more than once if you need to. It's all there. Okay, I think I've got that, and I know I am recording, so I'm going to stop sharing this screen. Yes, I am recording. We still only got a few people on. Well, it is what it is. You know, we're all going through something, but that shouldn't prevent you. You know, I got a kick. I mean, the college said that Monday's a holiday, and I'm thinking to myself, you know, what are people doing on President's Day? It's not like it's 4th of July, but it is what it is. People will find reasons not to, whatever. But hey, what are you gonna do? All right, let me share my screen. Going back to section 3.1, we've collected this data, all right? We had either population data, parameters, or we had sample data, statistics, and then we started organizing it. We put it into distribution list. We did histograms, lower limits and upper limits, you know, class range, and we did midpoints, all that good stuff. All right, so now we move to, now that we've collected the data, we've organized the data. Now in section chapter 3, we want to analyze it. We got a bunch of numbers, a bunch of data. Well, one of the things is, hey, what's the middle number, or what they call measure of center? Well, the mean, the average. You've been figuring out average since you've been a kid. You know, you got 5 tests, you add your test up, you divide by 5. All right. A mean is a measure of center. Now, of course, it's got its good points and it's got its bad points. All right. Mean is sensitive to extreme values. You know, you get a very large number, it throws the average way out of whack. All right. Sample means tend to vary less than other measures of central. In fact, when we move on, mean is the best measure of central tendency. The median, you're talking about the price of houses. All right. One of the ways we talk about the average price of a house in a neighborhood is to find the median price, the middle number. Now, if you have an odd amount of numbers, there's an exact middle one. And if you have an even amount of numbers, the videos talk about taking the two middle ones and average them out. A mode. The mode is the number that appears most often. And the mode's not used all that much. Here's an example of mode. Let's say you work at a clothing store. Or it may be even better. Let's say you work at a shoe store. Well, you're going to stock the size of shoes that are most, how can I say, most bought. You're not going to, you know, stock a lot of shoes size 18, but, you know, size 7, size 7.5, size 8. You're going to stock the size that sells the most, you know, the size that's used the most. The mode. The mode is the number that occurs most frequently. If I'm talking about shoe sizes, it'd be, you know, size 7.5, size 8. If I'm talking about waist size, I used to work at a men's clothing store, and the most popular men's size in a pair of pants was size 34, 30, most popular. So we would stock more of those. All right, mean, median, and mode. Um, the calculator does all that for you. And I'm not going to pull the calculator up because you've got those videos today to look at. Well, actually, you looked at them last Wednesday, how you find a mean, median, and mode by putting numbers into your calculator, into a list. Where people kind of get messed up is when I ask you for the mean, but I give you a distribution list. Well, you got four cars whose speed went between 30 and 39. Whenever you're given a distribution list, and I talk about this in today's voiceover, first thing you need to do is to find the midpoint of that class. So halfway between 30 and 39 is 34. Now, halfway between 40 and 49 is 44.5. But the idea is here, once you find the midpoint of the first class, you see that the range from 30 to 40 is 10. So once I know that my first midpoint is 34.5, I simply add 10, 44.5, and keep adding 10 all the way down till I get the midpoint of this class between 70 and 79 to be 74.5. Now, here's the deal. It's the midpoint. You got to find a midpoint. You put that into one list and you put the frequency, the number of cars, you put that into a second list. All right. And then the video shows you how the calculator returns the average of this distribution, the mean of this distribution, which in this case is 55.7. What else you saw in section 3.1 was, many instructors have weighted averages. Homework may count 10%, the exams may count 30%. That's not the case in our course, but in some courses, you do see instructors weighting the grades. It's weird. People never know how to figure out a weighted average. So I'm saying to myself, what do? You just trust that the instructor is doing it right? Well, the answer to that, I guess, is yes. To find a weighted average, it's the sum of all the scores times the weights divided by the summation of the weights. What's this look like? Let's say your midterm, you get an 83, and your final, you get a 95. The midterm counts 40%, the final counts 60%. Question is, you need a 90 to get an A. Well, in Massasoit, you need a 92, but anyways. So to figure this out, it's the score times the weight. The midterm was worth 40%. The final, you got a 95, that was worth 60%. So it's the score times the weight plus the other score times the weight divided by the sum of all the weights. Now, this is weird here. In all the examples, you're going to see the sum of the weights is always going to add up to be 1. It doesn't have to be in reality, but for our test purposes, the sum of the weights will be 1. Well, adding these two numbers, your weighted average is a 90.2. Okay, that was 3.1. All right, now I'm talking about section 3.2, and what I'll do here, I want to move this out of the way and start a slideshow from this current slide. Oh, actually, here it is right here. This is now section 3.2, which you'll be going over in today's homework. All right. An average is an attempt to summarize the data just using one number. You got a lot of data, and people say, well, what's the average? Here's an idea. You're looking for a new bedroom set. You're moving into your first apartment, all right? And you go to a furniture store. Let's say you go to on Route 24, I forget the name of the Jordans. All right, you walk in there and you say, "Hey, I'm looking for a new bedroom set. What's the range in prices?" The guy may say, "Well, on the low end, it's $500, and then we got a bedroom set here that costs $4,000. The range is between 500 and 4,000. All the ranges is the difference between the largest price and the smallest price. It gives you an idea. Well, hey, what's the range in prices? And a lot of times you say, "Hey, I don't want the cheapest one, but I don't want the most expensive one either." So that's range. All right, let's say I'm interested in buying a watch. All right, I go to 3 different outlets and I find that the mean price is $325 for a watch. Well, look at these prices: 30, 40, 600, 630, 101 and a quarter. Interesting enough is the range in these 3 different watches, 3 different stores, the range changes. In this case here, the range would be 630 minus, it's the high number, subtract the low number, the range is 600. But what's interesting here, the mean price is 3 and a quarter. Look at the second one. The range is only 475, but the range, I'm sorry, the mean is still 3.25. So sometimes, even the last one here, these prices here, the range is only 250. Take the high one, subtract the low one. But notice the mean, the average is 3.25. But these values look nothing alike. So what we need to do here is to find another measurement. Now, another measurement that talks about dispersion of data is called what's called a standard deviation. Hey, how close are these prices to the mean price? Well, in the first one, when I calculate the standard deviation, it's 335. Look at the second one, standard deviation 261. This one here is only 119. This one here has the lowest standard deviation. Why? Because the prices as a whole are closer to the mean price. What standard deviation does, it says, hey, how close is my mean to all of the prices? I could have some crazy numbers as you see here, and the average is the same, but the prices don't look anything alike. I mean, this ranges from 30 to 630. This goes from 200 to 450. So the standard deviation is a measure of spread. How close is all the numbers to the middle number? Is there a huge spread, or are they more compact? In statistics, standard deviation and sample variance are used to describe the spread of data about the mean. Now, I'll talk about variance and I'll talk about how you find the standard deviation. Variance is useful, but in a mathematical sense, it's not all that great. All right. Variance, the reason why it's not used because the answer is in square whatever, square dollars or square pounds. You may say, well, what the heck is a square pound? All right. You may be scratching your head about why you're calculating variance in the first place. The answer is you use the variance to find a standard deviation. You take the square root of the variance, and that gives you the standard deviation. Well, a couple of times I'll ask you on a quiz or homework, I'll say, here's a list of numbers, here's some data, give me the variance. The calculator does not have a key for variance. It does have a key for standard deviation. What you'll do is, once you know what the standard deviation is, you'll square that to go back to find the variance. Once again, there's no calculator key for variance. There is one for standard deviation. You'll find the standard deviation and you'll square it, and that'll give you your variance. This is a video here. I'm not going to show this. This is embedded into your PowerPoint. Now, there are formulas that will find the variance, and there's this formula that calculates the standard deviation. We're not going to use any formulas. Why did I have you go out and get a TI-83 or an 84? All right. The calculator does all the heavy lifting for us. I give you the formulas, but ladies and gentlemen, you'll never use these formulas, right? The calculator does it all for you. Sample example here. I'm asking you to find a range. Well, here's the high number. Here's the low number. Gee, 5 subtract 1, the range is 4. And they've actually used the formula to find the standard deviation. I would have done it with my calculator. All right, here again, he's showing you how to do it pencil and paper, but there's no need to. All right, your calculator will calculate the standard deviation for you. Now, how does it do that? Well, the numbers we were given in the previous slide were, if I can show, well, they were 1, 2, 3, 4, and 5. All right, so what I did is put those numbers 1, 2, 3, 4, and 5. Now notice I've got my mode set to 2 decimal places, and I'll talk about, you don't want to have your mode set to 9 places. 2 is about right, maybe 3. All right, so I put the numbers into one list. I go to one variable stats, I hit calculate, and there it is. The calculator very nicely gives me my standard deviation. Now, you'll see this sigma X. This is also a standard deviation, but we never use it. When we're talking about standard deviation, this is what I'm using on my calculator, S of X. S of X is for a sample. The sigma X over here is if you were told a population. You'll never use this one. It'll always be the S of X. So there's no need for a formula. Your calculator does everything nicely for you. Here's a case where we're given a frequency distribution. What you would have to do before you start doing anything is to find the midpoints of all these classes, put that into list one, put the frequency in list two, and your calculator will return the standard deviation for you. What I've got here, ladies and gentlemen, is doing it pencil and paper. Look at the mathematics involved. I'm not going to put you through all this. I mean, it's in a topic, but it's not that, the topic is not worth us going through all of this crazy mathematics. The calculator takes care of it for you. Here's what I'm talking about. You've got this frequency distribution. The first thing I need to do is to find the midpoints of all these different intervals. I put this into list one. I put the frequency in list two. Whenever you're given a frequency distribution, you're going to have two lists. The midpoints go in list one. The frequencies go in list two. All right, there they are. There's my list one. There's my frequencies in list two. I go to calculate one variable stat, and there it is. There it is in red. There's my standard deviation. Now, what if the problem said, hey, I don't want the standard deviation for this frequency distribution. I want the variance. I would take my answer, 3.24, and I would square it. There's a key for squaring on the TI, or simply take 3.24, multiply it times 3.24. That's if I was asking you for the variance. In this case, I wasn't. I just wanted the standard deviation. All right, standard deviation is the measure of how spread out the data is. It's used in a huge number of applications. It's used in finance. It's used in stock portfolios. It's used in manufacturing. It's used in polls and surveys. It's good to have the average, but all the numbers close to the average, or they're, it's like saying, all right, you ask the guy at Jordan's, what's the mean? What's the average price of all your bedroom sets? He may say $700. Well, does that mean they're all around 700, or do you have one that's, 100 and you got one that's $8,000? I want to know how spread apart all these numbers are, these prices. Are they close to the mean, or are they spread apart? All right, so that's 3-1. That's 3-1. And let me just close this out. And I want to open up my second one. Give me a second here. How am I doing on time? 11:32. Not so bad. Not so bad. Of all these sections in chapter 3, 3.3 is the one that usually gives people the toughest time. Let me share my screen here. Okay, so there I am, and I want to start my slideshow from the current slide. Move this back up top. You guys know this guy is over here? Anyone know who he is? Anybody? Remember Star Trek, Data on Star Trek? Hello? No? Percentiles, box, and whisker plots. All right. Make sure you watch this video on 3.3. Al does a nice job explaining it. It may be a situation where you need to watch it more than once. I mean, if you don't get the concept, play it again. I mean, it's why I put these videos up. You may need to. Focus points. Interpret the meaning of percentiles, compute the median, quartiles, and what's called a 5-number summary, and then make what's called a box and whisker plot. We won't actually make it. We'll actually talk about the numbers that make up a box and whisker. It's the low number, it's quartile 1, quartile 2, and quartile 3, and the high number. We'll talk about that in a minute. We've seen measures of central tendency in the spread of a set of data. The arithmetic mean and the standard deviation will be very useful in later work. However, because they utilize every data value, they can be heavily influenced by one or two extreme values. Here's an example. I said this before. we're in class. Let's say COVID's not around, all right? And I take everybody, I ask everybody, how much do you make? Well, the salaries, if you're working part-time, maybe you're making, five or $6,000 a year, whatever. So I find the average of all the salaries of everybody that's sitting in front of me. Let's say it's 25 people. All of a sudden, Tom Brady walks into the class, and I take Tom Brady's salary and I factor that in to find the mean. Well, guess what? That extreme value, he's making like $50 million. Well, obviously, that's going to really skew the mean of the whole class because he makes so much money. All right. In cases where our data is heavily skewed or even what's called bimodal, we often get a better summary of what's going on by using relative position of the data versus working with every number. All right, how we do that is working with percentiles. He says we know that the mean is an average computed by using relative position of the data. The median is the middle number. If we're told that the 81 is the median score on a biology test, we know that half the class, 50%, were below 81 and 50% were above 81. Median, not mean now. Median is the middle number. The median is an example of a percentile. As a matter of fact, it's the 50th percentile. 50% of the data falls below the mean and a median, and 50% of the data falls above the median. All right, let's assume that you scored in the 60th percentile on a particular exam. All right, here's your score right here, 79.5. If your instructor says, Phil, you scored in the 60th percentile, what that means is that you did better than 60% of your classmates. However, 40% did better than you. If you're on the 60th percentile, you did better than 60% of your classmates, and 40% did better than you. All right. We see that the 60% data, well, 60% below and 40% above. Scoring in the 60th percentile, well, maybe it's not the greatest, but not that bad. Let's assume we range everybody by height, and I tell you that your height fell in the 80th percentile. What that would mean is you were taller than 80% of everybody else in class. Obviously, there's some people a bit taller than you. 20% were taller than you, but you were taller than 80%, 80th percentile. All right. If I was in, let's say, the 20th percentile, I'd be somewhere around here. If I was in the 50th percentile, I'd be somewhere in the middle. But here you are in the 80th percentile. All right, so we've got 20 people in this class. So how you calculate the percentile is here you are right here. You're going to count the number of people that are shorter than you. If I count these people up, I found there were 16. 16 people were shorter than this person right here. All right, now there's a total of 20 people. Well, 16 that were shorter than you divided by the total 20 is 0.80. Well, 0.80 as a percentage or a percentile is 80%. That's how you do it. You arrange the data values in order. You find out how many data values are smaller than your target number. In this case, is your target person. You divide it by the sum and you change it to a percentage. 80% times 100 is 0.80 times 100 is 80%. Let me move this out of the way. If your score is at the 89th percentile, what percentage of scores were below yours? Well, 89% of them were. That's the meaning of percentile. Scores range from 1 to 100. Your raw score was 95. Does that mean that you were in the 95th percentile? No, doesn't mean that at all. I mean, you scored a 95, you may be in the 10th percentile. Everybody else in the class may have gotten a 97, 98, or 95. So your raw score is not indicative of your percentile score. All right. If you got a 95, doesn't mean that you're in the 95th percentile. You would have to find out how everybody else in your class did. Count the number of people who scored lower than you divided by the total number of people in the class, and that's how you would calculate the percentile. All right. There are several widely used conventions for finding percentile. the one we're going to be using, well, it's pretty standard. So the first thing you need to do is to rank or order the numbers from smallest to largest. That's the first thing you need to do. All right. And once you have the numbers ordered, you find a number of values that are less than your target value. You divide it by the total number of values and you multiply it by 100. In the previous example, there were 16 people shorter than you. There were 20 people in the class. 16 divided by 20 times 100 worked out to be 80%. You were in the 80th percentile. Now, notice it says here that we're rounding off to the nearest whole number. Well, you know, if the digit in the tens place is a 5 or higher, you raise your answer up 1. All right, you're rounding off. So here's some examples over here. It says, for instance, the number 65. Find out what percentile the number 65 falls into. Well, the numbers are arranged in order from the smallest to the largest. And there's 65 right there. Now, how many values were smaller than 65? Well, it looks like 2, 4, let's see, 2, 4, 6, 8, 10, 12, 14, 16, 18. It looks like 20 numbers that were smaller than my target number of 65. So 20, all right, the number of numbers that were smaller than 65, there were 20 numbers here, all right, smaller than 65. 20 divided by the total number of numbers you had, 24, all of that times 165 would fall into the 83rd percentile. Here's one for 41. Well, there's 41 there. How many numbers are smaller than 41? 1, 2, 3, 4, 5. All right, so number 18. There are 5 numbers smaller than 41. There's still 24 numbers times 100. The number 5 would be in the 21st percentile. Now, notice you're rounding up to the next highest whole number. All right, so obviously, whatever decimal there was, we either round it off or round it down, whatever, but you get the idea. All right, quartiles. And I say the word quartile, it reminds me of quarters. Quartiles are special percentiles. Quartiles are those percentiles that divide the data into fourths. You can have the first quartile, which is the same as P25. The second quartile is the same as P50. I say second quartile, Q2. And what I'm thinking of, hey, if I have 2 quarters, I got 50%. If I got 1 quarter, I've got 25. If I got a quartile 1, that's 1 quarter, 25%. If you're in quartile 3, well, 3 quarters, you're in the 75th percentile. First quartile is equivalent to 25th percentile. Second quartile, the median is the same thing as quartile 2. The third quartile is the 75th percentile. Just think of quartiles as being quarters. 1 quarter, 25 cents. 2 quarters, 50%. 3 quarters, 75. All right. We started out when I gave you a height and I said, what percentile did that person fall into? Well, you counted the number of numbers that was smaller than you were. There was 16. You put it over 20 and you multiplied by 100. The flip of this is instead of me giving you a number, you give me a percentile. Here, I give you the percentile and you give me the value that falls into that percentile. There's a little formula for this. All right, you take your percentile, you take it, you divide it by 100, and then you multiply it by how many numbers you have. But notice, it doesn't give you your answer. It just gives you the location of where your answer is. It may be in the 5th slot, the 6th slot, the 7th, whatever. Once you know that, you count, hey, what's the number in the 7th slot? What's the number in the 8th slot? All right. Now, to further complicate this, when I give you a percentile and I tell you to find out what number falls into that percentile, well, in the previous thing, we always rounded off, which means if the value in the 10th place was 5 or more, we raised the whole number up 1. When you're converting from a percentile to a number, notice what happens here. 2 things. When I do my calculations here, 1 or 2 things are going to happen. Either I'm going to get a whole number or I'm not. If I get a whole number, let's say I get a whole number of 5, I need to take the number in the 5th position, add that with the number in the 6th position, and find the average. If I don't get a whole number, I'm getting some sort of a decimal, I always, always, always have to round up. I'm not rounding off, I am rounding up. All right, so it gets a little tricky here.
Mhm.
Here's an example. Find a number that's represented by P20. All right, P20. I would take 20, I would divide it by 100, and then multiply it times how many numbers I have. This is number 19. All right, number 19. I would take 20, divide it by 100, multiply by how many numbers I have? 24. 4.8. Well, 4.8, if I was rounding up or rounding off, I'm still going to get to 5. 5 is not my answer. 5 is the location of my answer. I'm looking for the number in the 5th position. And here it is here, 39. So when you do this little mathematics here, it doesn't give you the answer, it gives you the location of the answer. All right, 20 divided by 100 times 24, 4.8, rounded up to 5. The location of what I'm looking for is, in this case here, the 5th number. Let me do another one here. Q3. Well, Q3, quartile 3 is the same as P75. It's like having 3/4. 3/4, 75 cents. All right, so number 21. I would put 75 over 100 times how many numbers I have? 24. Oh, wait a minute. I get a whole number of 18. So that tells me I need to find a number in the 18th position, add that to the number in the 19th position, and find the average. This only happens, ladies and gentlemen, is when you do your calculation here and you get a whole number. Here's what it says. If I get a whole number, I have to find that number and the next one and average them out. It's basically like when you're finding median. If you got an even amount of numbers, you get two middle ones. You average out those two middle numbers. So it gets a little tricky here. This box and whisker, there's a way of having your calculator actually do a box and whisker for you, but you don't have to. A box and whisker is a what's called a 5-number summary. You have the low number, the number in quartile 1, the median, and then quartile 3, and then the high number. All right. Low number, high number, quartile 1, the median, which is quartile 2, and quartile 3. There is no need to have the calculator draw this box plot for you. All you need to know are these 5 numbers. All right, so here's the case. Let me just tell you something. People get this one wrong, and it's usually the last couple. It's the last questions on the exam. By the way, there's 25 questions. And what I've done is I put it in the same order. In other words, when we started out the course, we started out with chapter 1, section 1, chapter 1, section 2. You'll see the questions on the exam follow that same format. They go in order: 1, 1, 1, 2, 2, 1, 2, 2, 2, 3, and so forth. All right. So he wants me to come up with a 5-number summary, a box plot. What I would do, the best way, the easiest way, the guaranteed way you're going to get these right is put these numbers into a list. All right, I put them in. And you got 6 different lists. I would say use list 1, because if you forget what list where the numbers are, you're going to be messed up. So utilize list 1. All right, in this case here, I put all my numbers into list 1. I went to one variable stat, and the calculator tells me everything I need to know. Hey, did I not know that the small number was 34? So him telling me that's no big thing. Did I not know that the biggest number was 79? Yeah, I knew that. What I didn't know was quartile 1, the median, and quartile 3. Ladies and gentlemen, put the numbers into the list. Your calculator gives you the 5 numbers that you need. No big deal. And to put these, what are they? 2, 4, 6, 8, 10 numbers. How long is that going to take you? I've seen some of you people text. It's not going to be a big issue. It's the guaranteed way of getting these problems right. Use your calculator. It tells you, it gives you the 5 numbers you need. Duh, like you actually need, here, you actually need to have someone tell you that 664 is the low one and 836 is the high one. No, but you do need to have the calculator tell you quartile 1, the median, quartile 2, and quartile 3. So what did I do? There's 2, 4, 6, 8, 10, 12 numbers. I put them into a list. I went to stat, one variable stat. I put in L1. There's no frequency because there's only one list. The only time you use a frequency when you have your midpoints in one and your frequency in L2. I've only got one list, so there's no frequency. And what's the calculator do? It tells me the small number was 664. Duh, I knew that. It tells me the bigger one was 836. Duh, I knew that. Here's what I wanted. It tells me what quartile 1 is, it tells me what the median is, and it tells me what quartile 3 is. The calculator is your friend. So what we're doing here, we're just making what's called a box plot. There's your low number, there's quartile 1, there's your median, quartile 2, there's your quartile 3, and then there's your high number. And the same thing here. The calculator gave you all 5 numbers that you needed. All right. Now, here's the case where we got, a few more numbers. We got 2, 4, 6, 8. We've got 32 numbers. Duh. Okay, so it's going to take you maybe 3 minutes to put these numbers into your calculator. But what's the upside of that? The upside is you're going to get the answer right. So take your time, put these numbers into your calculator. I did here, all right? You don't see them all, obviously. I put them in list 1. I went to stat, one variable stat, and it told me my smallest number was 100. Yeah, I could see that. It told me my biggest number was 134. Yeah, I could see that. But here's what I wanted. I wanted a calculator to give me quartile 1, the median, and quartile 3. Now, all of these have the right low number and the right high number. They always start off from 100 to 134, 100 to 134, 100 to 134, 100 to 134. All right, fine. All of them have the right low and high. But now what happens? Look, my quartile 1 is 108. Well, that guy has quartile 1 at 107. That is 107. These two have 108 for quartile 1. My median is 114. Well, there it is. We know it's not letter B, it's not letter D because they had the wrong first quartile. And this one here, they both had the right first quartile, but this guy said the median was 114. And according to my calculator, yes, the median is 114. Duh. I know it's answer A. I'm moving on. What did it take me? It took me about 3 minutes to put these numbers into my calculator, but I'm guaranteed that I can take this information and match it up with the correct letter. In this case here, letter A. It's a no-brainer. And how people get this one wrong is like, this is the hardest thing that we do in section 3. It's the hardest thing we've done in the first 3 chapters. There's no reason to get these wrong. Take the time, put the numbers into your calculator. It may take you 2 or 3 minutes most. You got 90 minutes for the test. It's not going to take you that long. Trust me. Here's another one. Let me move this out of the way. All right, there are my numbers from 310 to 3700. 310 to 3700. 310 to 37. I mean, all of these have the right low and the right high. But what I need to know is the right quartile 1, the median, and the quartile 3. Well, I put the numbers into a list, went to stat, one variable stat. My numbers were in list 1. There it is there. And nicely, the calculator says, oh, by the way, your low number was 310. Duh, I knew that. But it tells me my quartile 1 is 510. Well, that's 500. Can't be that guy. This guy is 500. Can't be that guy. This guy is 510 quartile 1, and that one there is also 510. Okay, so A and C are in the running. What's the median? 705. What's this median? 705, 705. Oh, wait a minute. Both of these have the right quartile 1 and quartile 3. Where's the discrepancy? Look at quartile 3, 1225. This guy has 2225. Now, he's not the one. Oh, there it is, 1225. I see it, quartile 3. This is your low. This is quartile 1, the median, quartile 2. This is quartile 3, and that's the last one. So these were close. This was the one that had the right number. All right, quartile 3, 1225. It's a no-brainer, provided you put the numbers into a list. Now it takes a little longer because there are 2, 4, 6, there are 24 numbers. Big deal. 2 minutes, 3 minutes on your calculator. You got 90 minutes. Not going to be an issue. And that, ladies and gentlemen, is that, and I did pretty darn good because I'm a minute shy. Well, actually, I'm 4 minutes over. So, do what you need to do. You got homework tonight. You got homework Wednesday. Monday, take the day off, but get ready because on Wednesday, because Monday's the holiday, the meeting we're having right now at 11 o'clock, I will do Wednesday, next Wednesday at 11 o'clock. All right. Now, what I would say to you is I'll devote the whole hour to go through any questions that you have. Now, here's something else that I've provided for you. Just hold on a second here while I just call this up. Let me share my screen here. Let me share my screen. I want to show you this. What I would say when you have the test on the what date I say it was, the 17th, I just enabled this right here. All right, these are the worksheets. I would have these 4 worksheets printed out by my side. Why? These are the answers, the solutions for everything that you're going to be responsible for. Now, the test questions aren't going to be exactly the same numbers. That'd be stupid. But they're going to be of the same nature. So if I see something done in section 2.2 or 2.3, I'm going to look at it what I'm doing for the test question and do it the same way, because in these solutions, I actually provide you with screenshots. All right, I actually provide you with, let me see if I can show this here real quick. This is what I'm talking about. See where I've given you, here you got a distribution list, and I show you how you find the median. You find the midpoint, you put that in one list, you put the frequency in a second list, and that's, I'm sorry, this is finding standard deviation. But the point being is, if you see a question like this on a test, you see how it was done in the practice. You're gonna do the same thing. Put the midpoints in one list, put the frequencies in the second list, and lo and behold, there it is, and the answer matches up perfectly. All right. I know that was kind of fast, but hey, it is what it is. It is what it is because we only have 15 minutes. The person, I think Jolene, I forget who asked me. Yes, I am available during the week. Shoot me an email. Let me know your availability, and we can do a private Zoom meeting for whatever time it takes, 10, 15, 20 minutes. I have no problem with that. But don't forget, I'm available on Fridays at 11 o'clock for office hours meetings. And trust me, where everybody else is today, well, I have no idea, all right, because it's snowing outside and who the heck knows. But I'm not going to you here. I was here. That's all that counts. Any questions?
No. And on Friday, you said we could just go into the Zoom, correct?
Been there for the last 2 weeks, ma'am. I've been there for 2 weeks. I've had 2 different people show up out of 25. I've
Well,
been there. No one.
I found the first and second chapters a little bit easier because I'm accustomed
I'm
to it.
not
It's just
getting on you, Jolene. Don't take it
no, I
personal,
know what
please.
I'm saying.
I mean, lighten up, Jolene. Stop whining, please. I'm just
I
teasing you.
okay.
Jolene, stop your wine. You want some cheese with that wine, Jolene?
Oh yes, definitely.
I'm just messing with you. I'm messing with you. You follow me, right?
Yeah, I do.
All right. I know. I know it was easy, but I want you to do well, Jolene. I want you to do well, Jason, Solomon, Donald. I want you to do well. Trevor, I want you to do well. I want everybody to do well. But I've done this for so many years. I know what it takes to do well. That's all I'm saying. Okay.
Okay.
All right. You're still my buddy. We're still friends, right? Stop whining, Jolene. My God. Yeah. You might be my first wife. Or was it
Oh
my
my
second wife?
God.
I'm on my 4th wife, Jolene.
That's sad.
No, it's not. I've been married to one woman for 50 years. You kidding me?
I remember you telling me that before.
Yeah. She could have done better. I could have done worse. All right. I'll let you guys go. And Jolene and I will talk about my ex-wife next time we do a Zoom meeting.
Thank you.
Hey, be safe, all of you, okay?
You too. Thank you.
Thank you. Have a good day.
Thank you.
All right, guy. Trevor, take care.